Hello there, welcome back to the Developer's Guide to Windows 10. I'm Andy Wigley.
Hi, and I'm Shen Chauhan.
Right, we just had
question.
we had a question. We just talked about background tasks, and do you want to just?
Yeah. So the question says, how do I consume or push data from or to a background task? Well, I suppose in this case, you've still got access to the local storage or the network from the background task. So
the background task is in the same, storage areas. Yeah. It has so you can just communicate.
It's got the same rights, yeah.
That's right. Yeah. So that's and the background task can do networking to the cloud and that sort of stuff.
Yeah.
So, and you could use manual reset events, I guess. So there's various techniques.
There's various ways.
Yeah.
But it's possible.
Yeah.
So,
right, so moving on to the next. This for me, this is a crucial topic, I think. So
yes,
and actually, I agonised over the title of this, and it's called Cloud Integration because that's what it is. But actually, it's also about connected experiences.
It is, because I think these days it's difficult to really build a great experience when it's not connected to the cloud and has that whole handoff with various devices. We live in a multi-device world, and we use them for all different things.
That's exactly
and a cloud way is a great way to integrate them.
Exactly. So it's all about connected mobile experiences, and that's kind of the alternative title for this. Connected experiences. So we're going to look at three kind of facets of our tools for building this kind of thing.
Okay.
Roaming data for simple stuff. OneDrive is one possibility you could use as well, but I'm going to spend most of my time talking about Azure and building a mobile apps backend.
Nice.
With various aspects of that. Just talk about that mobile experiences. If you think about, obviously portable mobile devices, everybody has at least a smartphone and probably has a tablet and maybe a couple of smartphones. Anyway, people have loads of devices, and now, and we're really excited about this being able to, with UWP, build one app that can run across all these devices. It's really great. But what wouldn't be great is if your user picks up their phone and they enter to-do items onto their phone, and then they pick up their tablet and their to-do items aren't there.
Yeah.
Some apps can work in isolation on the device, and that's been the mindset from the beginning. As you're creating, it's all the experience was centered around the device, not about the user. So and these devices have led to revolutionary experiences, and they allow people to bring these rich computing devices with small size and portable, battery powered. And that's really, really great. But we need to think about this connected experience. You've got to make sure that the user can put down one device and pick up another and continue their experience. So, you want to say that the user is the center of the experience, not the device.
Yeah.
That's right. So although we've given you great tools for creating these apps and runs across all these devices, you've still got to do some extra work to make sure that the experience is available on the right device at the right time. So Universal Apps helps you to do this. It's about creating these shared mobile experiences, whatever the device.
Yeah.
So how do we do that? How do we do this, storing stuff in the way that can go across different things? Well, one of them, we actually have built into the UWP, we have these roaming data APIs. And what these are is two things, a settings dictionary and a folder called the roaming folder and the roaming settings.
Settings, yeah.
And you can write stuff into the roaming settings and you can store stuff in the roaming folder. And then magic happens because the system will take care of syncing anything you put up there up to the cloud.
Your cloud,
Your cloud, whatever your cloud is, and we'll talk about that in a little while. Well,
it's OneDrive, isn't it?
Well, it is OneDrive, but there's actually a subtlety here. Is that as part of the Windows 10 wave, and we're still sort of working on this, and more details will come out. But essentially, when you set up a new Windows 10 computer, right after you. Does anybody put DVD in anymore? Why when you put the USB? No, exactly. Yeah. Well, when you start the install right early on, it will ask you. Essentially, is this a work machine or a work or school business machine, or is this a personal machine?
Yeah.
And if it's a personal machine, then your cloud storage is OneDrive, consumer OneDrive. If it's a kind of work, business, school kind of machine, then that's different. So the consumer one, you to use Microsoft services, you authenticate against your Microsoft account, Outlook.com or whatever, your Hotmail or whatever. Yeah. If it's a work or business thing, then you're authenticating against your business authentication, which will be probably Azure Active Directory.
Yep, AAD.
Yeah, and the roaming, if it's a business machine, first 4 apps that have been installed from the business store, which we'll talk about later this afternoon. Yeah. Then that roaming goes through OneDrive for Business. But actually, from an app developer's point of view, there's no difference. It's just
really
roaming
have to worry
data.
About it,
you don't have to worry about
it.
It just happens.
You just set your app to go.
Yeah, so this magic happens. It syncs it up to the cloud and then syncs it down to any of the user's other devices. So if your app is running in both places, it gets that sort of thing, which sounds fantastic. It does come with a few caveats, which we'll come on to. But anyway, how you store stuff with roaming settings, it's just a dictionary, store stuff in it, like that. There's also, it's just a dictionary key. There is a special key called high priority, but that's actually only observed on Windows desktop family. So if you store something with high priority, then it's synced straight up to the cloud, so really quickly. But if you do that on Windows Mobile,
it has no effect.
It's still a valid key, but it's just treated like any other item.
Okay.
And then this is how you actually read stuff out of there. So it's just a dictionary, so no great surprises there. Here's the roaming folder, so you can just create a file in it, just the same. It's just a folder, just the same as your local folder, as any other folder, the temp folder. So it's a storage folder, and you store storage file objects in there, and you treat it exactly the same, and you just write files into it. Except that, as long as they're less than 100 kilobytes in total, they will get synced up to the cloud.
So that's the key thing, 100 kilobytes. So you don't want to be saving up, music and all the rest of it.
No, that's right. And actually, that's not a lot of data, really. No. So it is only of limited use. This.
It's more for reference. I'm trying to understand what's happening. Okay.
Now, if an app is, if you've got a foreground app that's running on one of your devices, and they pick up their other device, and the app stores something into roaming settings, it gets synced up to the cloud, and then the sync engine underneath syncs it down to the other device. If the same app is running and you have registered for this data changed event, you'll get an event fire in your app if it's a foreground app on a device that's just receiving updated roaming data.
And how does it deal with like merge conflicts and stuff? Is it clever enough to
Well, again, this is the other caveat. It's last writer wins, so there's no...
So if one device has got a slow connection and it's sort of a bit behind, you'll end up getting stale data. So something to be aware of when you're developing that.
So this roaming data really is only for settings and something that is non-critical data. Yeah. So typically for preferences and that kind of stuff. So and you actually see it on Windows. If you set your accent color on one system, set it to red on here, and then you pick up your tablet later on and go, oh look, the screen's gone red. It keeps them in sync.
It's like an equivalent of like a cookie, I suppose, in some sense.
Yeah. So anyway, this event is useful to be aware of these changes. Debugging roaming data is a bit problematic, actually. Yeah. So you obviously, if you want to test this sort of thing out, you can install your application onto multiple developer unlocked devices, and we told yesterday, right at the very first session, you don't have to. It's all it is going to settings, developer unlock, and just check a checkbox. Now it's really easy. But then, typically, to actually cause a device to trigger an update, you've got to kind of lock it or something, or get the lock screen up. Yeah. So a phone, you kind of turn the screen off and let the lock screen up. And if it's not kind of happening, you've got to make sure all your files are closed correctly, and also make sure that all your devices are running the same update and this kind of stuff. So it can be tricky to get this thing to trigger.
Debugging while the screen is locked.
Yes, exactly. And I'll give you a simple little example of roaming data here. So here we've got it's this very, very simple app, this roaming settings demo. So I'm going to go deploy this, and as you can see there, we're running it. Actually, this is a real phone. Project My Screen app is up on there, and we're going to run this install. And you see here we go. We've got a nice. It's a very rich app with a red background. You can change it to a green background. Yeah, good. And we can change to x86 and run it on the local machine. We just deploy it to our local machine. So we can actually get the two running up side by side. So we've deployed it, now we can run it. So here we are, here's our desktop version running next to the phone version shown in the Project My Screen app. Now we can change it to green, and it will have written that to to the local roaming settings dictionary, but it won't necessarily have synced it yet. So actually what we do is we'll just suspend the app and actually turn the screen off.
Okay.
So that should, if the gods are with us, cause the sync to go. Oh, there we go. There you go. So then it's synced up and change that to green. That's as exciting as it gets for roaming settings, really. You know, and we could change it back the other way. So so you get the idea. Very nice and simple. This is the event handling. So you can see we've got hooked up the Windows storage application data .current data changed in our on-navigated to. And when that event fires, we call this set background from settings. We're using dispatcher there to make sure it runs on the UI thread. And this, we really go off and read that roaming settings dictionary and just set the screen background to be green or red according to whatever we find in there. So that's how the actual app was able to respond automatically to that. Great stuff, eh?
Very simple.
It's very simple, yeah. Now, like we were saying, I think by now you've got the idea that this sounds great, but the key thing here is it's good for app customization settings, for preferences and that sort of thing. Most recently used lists, that kind of stuff. So so that you can share that experience across the devices, so that whatever they were last looking at, they can pick it up when they open the same app. You know, that kind of stuff is good. But you want to make sure you don't get over 100
so we should be clear, when you say 100 kilobytes, are you saying the roaming settings for the app, or is it a roaming setting sort of
for the app?
Key?
No,
okay.
For the app.
For the whole app?
For the whole app, yes.
Yeah. Okay.
It's not a lot of data.
No.
If you exceed that, you don't get an event or anything either.
So how do you know? You
start getting irate users. Yeah.
Right.
But your app won't stop working.
They
just carry on. The syncing stops, so they end up working in isolation. Yeah. So it's bad for synchronizing large amounts of data or instant syncing scenarios. Last writer wins, and also the data is deleted from the cloud if the app is not used for a period of time, which we don't actually strictly specify.
Okay.
But it is around 30 days.
Okay.
So if the user doesn't use the app for any time, the user doesn't see this data in OneDrive, so it's kind of hidden away.
Yeah, it's hidden away. You'll never see it, so they can't accidentally delete it themselves or anything.
Do not use roaming data as a general purpose data synchronization mechanism.
Yes,
I think you've probably got that point. Now, there's a complementary thing which also does roaming. So there's a lot of roaming going on actually throughout Windows about sharing this experience across different things. Credential Lock is really, really useful. So you can, it's an API to store credentials securely. They are encrypted. And you obviously, these also roam across your different devices. So it allows these scenarios where you can actually prompt a user for some credentials in order to access a service or something. You can store that data securely in the credential locker, and then if they run the same app on one of their other devices, they don't have to enter the username and password all over again.
Because it's linked via your...
Because it's been roamed across
your account,
and it roams across the trusted devices. And as we say, for personal devices, apps that are stored from the public store, you're roaming through the public OneDrive, their OneDrive account. If it's a business system, business store, then you're roaming through Azure Active Directory secured business cloud storage. But essentially...
And it's all encrypted on the device as well, right?
It's all encrypted end-to-end, so it's safe. This is how you use it. It's a password vault. You just store password credential objects in it. You give it kind of a resource name and then a username and password. And then you add it to the vault. And then you can actually, there's a couple of APIs. That's one example. You find all by the resource name. You just pull them out, and then you can pull them out and make use of them. So that's just very briefly on Credential Locker. So that's a really nice, useful API as well. It's just a secure roaming settings, I guess. Now then, so that's all right. But if we want to say, we said that this is, we want to actually have a proper data storage solution.
Yes.
So we want something that's going to work.
Robust, more than 100K.
Yeah, that's right.
That sort of stuff.
And really, there's two things to think about. You could actually store bigger files in OneDrive. You could design your app around that, and a good number of people have done that. So, and the advantage for that is that the storage in the cloud is owned by the user. Yes. Not by you as the app provider. So it allows you to still ship your app as a free app and not have to worry about the cost of cloud storage. Because the other one is to store it in in the cloud.
Yeah.
Something like Microsoft Azure.
Yeah.
And that's what we're going to go on to in a minute. But let's look first briefly at this OneDrive example.
Okay.
So this is where we can actually, you could store stuff in the cloud for, and obviously its primary use is to store for personal documents, photos and files that can be accessed from anywhere. So it is best used for user-owned content. Let's be clear about this.
Yes.
So using it for app content is actually, you kind of have to, and with this one, you're going to be storing your files into a folder that is entirely visible to them. So they could delete it.
They could delete it. You could be at the mercy of the user doing things to your files which you don't want them to do.
So my advice for you would be, you might, for example, want to ship a version of your app that says, the free version, the trial version says, do you want to synchronize data across your devices using your OneDrive? And you get them to confirm that they do. But obviously your app would have to handle the situation that they come along later on and deleted it, then, well, they've deleted their data.
Hey, yeah.
But if you get their buy-in, then you could still ship the free version of your app, and then maybe you ship a paid version, an upgrade, an in-app purchase to say, do you want to synchronize through our cloud service? And then presumably offer some more services and that kind of stuff. But that's for you, a business decision. But you've got OneDrive and OneDrive for Business. We're converging the APIs for accessing OneDrive and OneDrive for Business, so that from a app developer's point of view, it's the same. So you don't really know, and you may wish, depending on your app, again, you might have a hybrid scenario. So you could choose to store in one or the other, or you can just be agnostic about
just
it.
Say, I don't really care where.
Just use the OneDrive, whatever it is. So. There's a very active team working on supporting developers for OneDrive, and they've just actually published a whole bunch of great samples.
Oh, wow, okay.
And a lot of this is tied in with Office 365 as well. But you've got two pathways to add OneDrive integration in. There are file pickers and savers APIs, and and also the other thing about this as well is clearly we are client agnostic. This is a cloud service, so we want you to be able to create apps for not only Windows 10 devices, but all the available platforms. So all of these APIs, they all support JavaScript, iOS, Android, and obviously Windows Universal apps. UWP. So there's pickers and savers are easy to use APIs for quickly allowing the user to pop up a UI, select a file, and save files back. Then there's the OneDrive API for deeper and more robust integrations, where it's a rich web API that enables full integration. So our first-party applications are built using this API, and you can use it as well. There was a really good build session on this. The new OneDrive APIs for developing against OneDrive and OneDrive for Business. You can check that out on Channel 9 and get a bit more information. So as a very, very quick and brief introduction to this, this application here is one of the samples that's just been published up on GitHub, Office 365. I want to call out just one thing about it, and then I'll show you. It connects to my OneDrive for Business, and it allows you to use as a flip view to just look at some photos. Just as a nice example. And it gives you, it's an example of some of the plumbing to actually go up and enumerate folders and discover files and that sort of thing. But one of the most interesting things about this is not about OneDrive at all, but there's a new API in Windows 10 UWP, which is the Web Authentication Manager, which allows this single sign-on kind of thing. So it means that if you've got a system and you're already logged on, and I'm logged on this system, I'm logged on to my domain, it's at Microsoft.com, it may or may not, depending on whether the token has expired. It probably, first time I run it, it might prompt me to
probably for your credentials, so you can get the token,
as a check.
Token,
But if I run it again, it won't. It will single sign on. It will silently log on, and that's all managed for you by this Web Authentication Manager. So I just wanted to call out that. That's the bit that does all that. To enable you to handle this kind of situation.
These days, users are always getting used to this whole single sign-on process. It's almost become like the expected.
It's so annoying him to entering your credentials all the while, and you're thinking, well, it knows what machine I'm on. I've already logged on. Why not just do it? So just starting this up. Here's the UI. And it's probably trying to connect. I did run this, and it didn't ask me for credentials. And this has gone straight to my This is my my
top
personal
secret.
top secret stuff.
Yeah.
So I'm going to have to kill anybody who's looked at this. So. And actually, it does actually allows you to look at this couple of photos I got from holiday. Had a nice holiday rock climbing in Sicily.
Oh yeah.
That's not me. I took the photo.
Oh right.
And it's a flip view, so you can it's pulling these down from. Oh no, that is me.
That is you.
God, I was going well that day.
Yeah, you're a adrenaline rush right there.
That was steep, man. That was good. Sicily, very highly recommended if you're a rock climber. So this little app is going to be in the sample, so you can you get the idea of this, and you can use it as a basic model for accessing files on OneDrive, OneDrive for Business in this case, but as that. Okay. Now then, most of this I want to talk about Azure, app service, mobile apps. So many of you may have heard of Azure Mobile Services.
Yes.
Which is still currently our live product for easily building a cloud-based mobile backend. And what a mobile backend is essentially a database.
Yep.
By default, you get SQL Azure, but you can actually configure it to connect to MySQL. You can connect it through to your on-premises SQL server. So but out of the box, you get SQL Azure. And it's easy wizards to configure it all. You create tables, and it will automatically modify the schema, and you just send it some JSON data, and it
pretty much just sorts itself out, really.
Yeah, it's not really so easy to get set up,
nice.
And supports lots of great features, including authentication, push notifications, offline sync.
Like
I'm going to show you some of those features. Now we've got a new offering that's coming out called Azure App Service Mobile Apps, which will replace in time Azure Mobile Services. Okay. So I'm concentrating on the new one. So mobile apps is a part of this new offering called App Service, which brings together a couple of things that we already had before, which is web apps and mobile services, if you like, the new version, mobile apps, and adds a couple of other things, API apps for easily building a REST service in the cloud, and logic apps, which is about workflow automation. And all of these, the interesting thing about these is they all work within the same container, so it's really easy for you to build integrated collections of services that share the same authentication gateway, and then can kind of cooperate. And you get charged. It's just one price for your app service, whatever you use in there.
So actually, it's quite a good level of enrichment you're getting from using this service, I suppose.
Oh yeah. It's really exciting. It's still in preview. But it's been in preview for a while, so I'm sure the Azure team are working very hard to get to a full public release of this before too long.
So it'll be pretty stable, but probably not ready for production.
At the moment, that's right. So from a runtime point of view, API apps and mobile apps sit on top of web apps. So web apps is Azure websites, but it's exactly the same. That one's pretty much the same. Mobile apps is very closely related to mobile services and gives you all the same features, but actually has been re-architected a little bit and it got some improvements. And then API apps and logic apps I mentioned briefly there. Okay. So this integrated set of things. So with an app service, you're creating this web and mobile experience that share data across and building these integrated things. And like I said, it's one common billing model for all of your app services. So it's nice and simple to see what you're using there. And using a common gateway to authenticate. Right, let's get started because it's going to be mainly demo with this. Let's go on and actually, first of all, let's create ourselves a new Azure mobile app. So I'm up on the new portal. You go new web and mobile app. And then you need to enter the name of your service. So let's call it, it's going to be a backend for our to-do sample. Okay. To-do 10.240.
Nice name.
Never put a version number into a name, but there you go, I've done it. Now you need to select what your database is going to be. You can create a new one up in the cloud, or actually I'm going to use one I've already got. Okay. That one. So I'm going to select test MVA mobile app DB, and I need to put my administrator password in. And then you click OK. And there's other things you can set on it, but that's the basics. So now we can just hit create, and then we go and make a cup of tea for a couple of minutes or something. We wait a little while. And this is now doing all its clever stuff up in the cloud. It's configuring a website, an Azure a web app, which is going to host our REST service. So which supports CRUD operations against our data table. So we've got SQL Azure at the back, which is storing the data, obviously. We've got our website, which is hosting the REST services.
And this is doing it all based on the database schema, so you've not had to write an API or a REST-based service. You've just gone, here's my database schema, and it's gone.
Well, actually, at this point, we haven't specified. All it's doing is creating, the potential. It's kind of hooking you up to this back-end server.
A blank database at the moment.
A blank database at the moment, and nothing in the service. But this is kind of building the plumbing and everything. So the really interesting thing about Azure, these things, there we go, is that you send data to it, and it will automatically configure. It will see. Well, you'll see the code in a minute how we actually sort of set this up. So, all right. So that's our service. We've got our thing up here. Now we can add our existing. We've got an existing client, so we want to add our existing to-do app to this service.
I see.
So you go. There's two options. You can create a new app. It's a really good tutorial that you can download and run through. But I'm going to download. This is my server code. So first of all, I've got to download. I'm going to. There it is. To do 10.240 runtime. First of all, we're going to run a PowerShell prompt and just unblock it, so we don't get rid of those annoying file access things. So unblock file. To do.
You can also right-click on properties and check a box.
I never see that. Didn't see that turn up on my system. I don't trust it. I've just got used to using the PowerShell. And extract all that, and I'm going to drop that down into a folder here on my system. MVA demos. This is where my client is. I'm going to put it alongside my client.
Makes sense. Yeah.
Yeah. To do cloud. So this is the .NET code for my back-end service for this thing.
Okay.
So let's open it up. It opens up in Visual Studio 2013 by default, but I want to work in 2015, so we'll do that. And then we need to change some code in it. So it gives you this ready-to-go sample solution based on the tutorial, which, funnily enough, is a to-do service itself. Just to keep things in the same family. Okay. But it's not the same field, so I need to make some modifications to my model. Theirs only has text and complete in it.
Oh, right, okay, yeah.
Let's build it first so it gets all the NuGet packages and gets rid of all those red squiggles. So all that web API stuff going in, all those NuGet packages, OWIN, Entity Framework, Automapper, a bunch of stuff.
There we go.
There's quite an impressive list of NuGet packages on this. There we go, that's resolved. Now, so text and complete is no good for us. This is actually our model from the client app.
Okay.
So we've got loads of properties: ID, title, due date, is complete, details, his favorite, you can see, and we've got an image on this as well. I'm going to talk about the images in a minute because I'm actually docking that one right now. I'm going to follow up. So, but I've got a snippet with this is the server-side version of our model, which matches what's in our client app. So we resolved that date time. I've got some things commented out at the bottom there which are for future expansion, which I haven't got time to do right now. I'm going to follow up on my blog and follow up with that bit. Now this here is in Web API config is the seed code that runs when we first run the system, and it's going to create the new table. So we basically throw at it a new to-do item based on our new schema, and I'm going to plug in we're going to create 2 items on the cloud, which for free, to seed it with a couple of items.
Just to make sure it's not just an empty database.
Yeah, I mean you wouldn't do that in a production service,
no,
of course, but here we go.
It's just nice to have.
This is where we publish it. So you can go up to now. Okay, now sometimes what you should get is a squiggle there, and it should show you, but sometimes this doesn't work. So the fallback for this is go off to your portal, and you can go and get, if you can go and drill down, it does happen sometimes, it should just give you that in that drop down, you should get it. But if you go to the mobile app code, this is the Azure mobile, the website where it's going to be, you can get the publisher settings for publishing up from Visual Studio. So it should have worked automatically. So instead I'm going to import my publisher settings, which those are the ones I just downloaded. Open it up. Okay. And now it knows where to publish this up to our Azure website. So now we just hit publish, and now this is building that code up, and it's shipping it all up to Azure and installing that onto our Azure website. So this is our server side for our mobile service, for our mobile app. So it's adding all that stuff, publishing up, and if the gods are with us, we should in a minute see.
So you'll start basically.
We actually have our service up and running in the cloud. Yeah.
And you'll be ready to sort of.
Now the interesting thing, you know that web API config thing with the seed code
Yep.
where it creates it actually doesn't do that. So I could go on to I could go on to SQL
right.
Server Object Explorer and go and look in that database, and it still won't be there. It doesn't. You have to make the first request.
It's got to make
on the very first request. It will do
context,
it.
right?
Here we go. Right, got our mobile app. It's up and running. So you get this nice friendly screen just to say everything is good in your world. So that's
fantastic.
Really good.
Yeah. So now you've got to go and initialize.
Right,
the
now we go
database.
back to our client. Now here you see this. I've got this code already ready in your app class. You need to put this. You need to put the address and details of your mobile of the mobile app code site. So
okay.
And if we go back to the connect an existing app thing again, it actually gives you the code there. Well, apart from there's a little bug in this at the moment. That third, so we'll copy that anyway, and we'll post that in. But you see that your application key, we meant to have that third parameter is meant to be supplied for you as well. There we go, let's keep the comments. That one, we still need that. Now you can get that actually from the settings up here. There's the application key. So we can just copy it. Now normally that's included in that comment block.
I suppose
it's
still work.
It's
still works preview, still work in progress.
So you need to plug that in manually. So there we go. That's client configured, and now I've got in this version of this image URI as well. I'm not sending that to the cloud at the moment.
Yeah.
Like I said, I'm going to follow. With the images, I'm going to follow this up with a blog post and show you how to store the images in Azure Storage as well to work alongside your mobile app. Yeah, but for now, anything that comes down from the cloud, I'm going to put up a not found. This one.
Okay.
It's just because we haven't got time this morning to run through this whole thing. So, right, let's run our client, and this will make a call up to our. Now we've plugged in that connection stuff. We'll make a call, and we should end up with it initializing the database. It will pull down the objects from the cloud, and what we should see is those two items. It's loading, so now it's going off to the cloud, connecting to our service.
Yep.
And there we go. We've got our first item, second item. Those are the ones we created in that seed method and in the back-end service. And we can now create one on the client, say store this in the cloud. It's storing it locally, and it's gone up, hopefully, to the cloud. We hope.
Fingers crossed.
Yeah, but we can prove that because let's switch to a different machine. Let's run it on. Let's run a phone.
Yeah.
Let's run a phone. So
That's
this is about this connected experience.
So now this is going to pull that from the cloud.
This will pull it from the cloud, and we should now see those three items up on this phone. Once that's booted up. And I'm fairly confident this is going to work.
Yeah.
So that's installing that onto the phone, and is that
Drum
splash
roll.
screen. Now connecting to the cloud, and get rid of the keyboard. There it is. That's the one we created on the desktop. There we go. I've got all those details there. So really cool. Great. So we've got the basics of our service working. We've changed the schema. We've got it synced up with our model. So and all pretty simple. So that's kind of that's a good start. And like you see, this is very easy to configure these backend data types. Now with a JavaScript backend, which they say they're going to support in Azure mobile apps, but they don't at the moment. At the moment, it's only .NET backend.
Okay.
Whenever you change the schema subsequently, it actually drops the table and recreates it, which is probably fine during development, but not something you want to happen, obviously. Now with the JavaScript one, you just send it new JSON, it will automatically scale. It'll have this dynamic schema thing. So, but there is in the documentation it tells you how to use entity framework data migration.
Yeah, it's the data migration on entity framework, and you can sort of set migration steps and roll forward and roll back, and you can change
so there's all kind of stuff for enabling you to grow your service over time and add columns and that sort of thing.
There's loads of goodness around that.
Yeah, but during dev, it's really nice and easy just to make changes, and it will automatically keep in sync, and that's pretty good. Now, what we showed you there is an online solution.
Yes.
Now, I've always had this thing about mobile app development. I come from the old days. I made my living writing ruggedized, logistics apps and this sort of thing. And all these people carrying these big devices around, and you sign on the screen, all this sort of thing. Yeah. And obviously, they all work on cellular data. And as we all know, even today, cellular data is not reliable. Yeah. It's not reliable. You have to have an offline story. And for, and not every app needs it, but it's actually a real, for many apps it's absolutely critical. And the best mobile apps handle network interruptions gracefully. So you've got to give, either way, you've got to give, if you're a networked app, you need to handle offline. You either just say, sorry, come back later, or better still, maybe give them some level of offline operation so they can carry on working. So, and actually adding offline sync is an incredibly hard thing to do, because you think if you've got an app with multiple users, for example.
I've tried it in the past, and it's horrendous. Like it gets terribly difficult.
It's a difficult thing to do, and because you've got all this problem of synchronizing and keeping things time stamped, and collisions and all the conflict detection, and it is hard to. It's one of those things like cryptography. Don't roll your own. You choose some solution off the shelf. People have worked out all the hard stuff for you.
Yeah.
An Azure mobile app has a brilliant story for offline sync. And it's really easy. So why do this? Well, obviously improving the app responsiveness by caching server data locally. You make them resilient. You make happy users. That's really the kind of thing, isn't it? Really the best.
That's what everyone wants.
So how it works, from the app point of view, you just still keep on reading and writing to your entity tables.
Yeah.
And actually, from the app developer's point of view, you don't actually really have to know. Your app will just carry on working, and it will cache stuff locally. It uses a SQLite database on the client device. And the other thing I haven't really stressed is all of this stuff, Azure mobile apps, is not just about Windows clients. It all works. SQLite is a open source cross-platform database, and this solution works not only with our client devices, but also with iOS and Android and Xamarin and HTML5 clients as well. So it's really, really cool.
So it's very flexible.
Yeah,
very flexible.
And it uses like a soft delete. So when you delete an item on the client, it doesn't actually just blow it away. It actually sort of stores a little record in a deleted items table. It just
flags it as deleted as opposed to actually removing the row.
Yeah.
Nice.
Yeah, so let's, and actually adding this is really incredibly simple. So the first thing we do is on the client, we want to add a extension SDK, SQLite. We need SQLite on the client. So first of all, we'll add that. I've already installed you can get that from SQLite.org or from the tools and extensions. We also need to add in Windows Azure mobile services SQLite store. So there we go, that NuGet package.
Okay, yep.
So this is giving the smarts on the client for handling this sort of thing. So OK on that, and accept that. And next we don't have to change the backend service for this. Now I've got in my repository class that's handling the interface to my data, I've got already commented out, I've got the code that we need in here. So essentially all you do, instead of working with iMobile Service Table, you just change it to iMobile Service Sync Table. But apart from that, the patterns just work the same. You still you delete async, insert async. Just every time you make a change, then we call this sync method, which I haven't defined yet.
Okay.
So then insert, update, delete, then we just sync. And here is where a couple of methods that are all we need. There we go. To do this sort of thing. So first of all, there's an init local store. This actually initializes on the device, sets up our local database, which is called localstore.db, and initializes the sync context. And then below this is a method called sync async, which does the sync. Now we need to initialize that. So a good place to do it is in our main page view model, in the startup logic. The first time we load devices, let's call to-do item repository dot init local store async. So this is where we're going to set our client up for doing the sync.
Okay.
And actually that's it.
Oh.
From the client side of things. Oh, we haven't got any sync conflict stuff, and I'm not going to do that today. But in terms of getting a basic offline thing working, that is it. Doesn't change on the back end. But the interesting thing is the tables, if we looked at it on SQL Azure, when you ever create a new table, it adds some extra columns to every entity, like last updated timestamp and a deleted flag. And
so essentially, Azure's already thought of all this, really.
This complicated
so you don't
stuff.
Have to.
This complicated bit of doing sync, they've handled all that. They've put all the tracking tables into the back-end storage. Now, I'm going to run it on the phone, simply because it's easy to make a phone emulator go offline.
Yes.
Tricky to do it on anything else. So
it's probably not wise during demos.
No. So here we go on the phone. First of all, let's just prove that it actually still works. We're online at the moment. It still works just the same, even though we're now on this SQLite table thing. sync table rather than the sort of vanilla one. So we're still going up to the cloud at the moment, getting our data, and life is good. Okay, let's just close that, and then before I run it again, let's just make this emulator go offline.
Cool,
so in the extra settings here, there's a network tab. We can enable network simulation. You can enable slow networks and fast networks, but you can also enable no network at all. So we're offline. Let's run it again. And this app is got already written into it. Has got a couple of, whenever you get an exception, you will get a message. But this is deliberate. So pull failed. It says error occurred because it was trying to sync with the cloud. We're offline now, so I'm going to create an item when offline. So as far as the app is concerned, now it's trying to sync, but its push has failed. And obviously you wouldn't show this in a production thing. Sure. But the app carries on working. We're storing stuff locally at this point. So we've got 4 items on the phone.
Yeah.
But if we run it obviously on desktop, then
because it was offline, we haven't got the sync.
Right? We wouldn't. We should still only have the 3 items because we haven't. This one is still connected to the cloud, but that 4th item hasn't gone to the cloud yet. So here we go. We're loading it up. Still the 3 items, as you'd expect. Yeah. Right, now let's just go and put the phone back online. So we'll turn that off again, and actually we can just simply run it directly. We don't need to debug it or anything. So we're running it locally, and this time it will. It's already. We haven't got an error, so it's clearly synced to this cloud service. Online, So what should have happened is now that 4th item will have been synced up to the cloud, and if we run the desktop one again, we should see that turn up on the desktop client. And there we go. Yeah, nice. Great. So there we go. And so you can see how that all works. That's, you know, it's really, really nice and simple, really.
It's a very nice, neat solution.
It is. It is. It's a good solution. Yeah. All right. So sync conflicts. I'm not going to implement this, but we need to just talk about it because it is an important part of a sync solution. How do we handle this? So you can have server conflict resolution or client conflict resolution. It means when a conflict is detected, you can choose to just say, "I'll have logic on the server to sort it out," or you can actually alert the client and say, "What do you want me to do about this?"
Maybe,
that's right. And it uses this thing called optimistic concurrency. So the idea here is that we've got obviously a service in the middle. We've got a couple of devices, which is not both ours, as you can see. Yeah. So device 1 creates an item which we'll call 1, and happens to be a triangle, and that creates that, and it's stored up in the cloud. Yep. And then, so the current situation is that both the cloud and device 1 have got version 1 of this object. Yep. And then device 2 syncs up to the cloud service, and of course it gets version 1 as well. Yep. And then device 2 modifies version 1, but it hasn't actually synced it up to the cloud yet.
Okay, so it's still offline.
So it's still, the logic hasn't synced, whatever, for some reason. And that actually changes it to version 2. So we've then gone to a square to represent that. Now it does update it to the server, and so now the server cloud has got version 2, and that's our current situation. And then, but then what happens is that device 1 changes it, but is offline. So it tries to update, and at that point the server is going to detect a conflict because. Because device 1 has gone from version 1 to 2, whereas the other one has gone from 2 to 2.
And it should have gone from 2 to 3.
The two version 2s are incompatible because the timestamps don't match. So we've got a sync conflict. So at this point you can then execute some logic to sort this out in some sense. You might just choose last update or wins.
Yeah, because you normally get notified saying there's a conflict, and then it's up to you to do whatever you need to do to make sure the user gets the best experience.
That's right. So it supports primarily online and occasionally it's connected. All this works with a variety of server data stores, and it all works cross-platform for the client, and it's very flexible and powerful. We've got a question here. How efficient is the offline sync? Will it handle large amounts of data? Well, the sync is under your control as the app developer as to what tables you sync and this sort of thing, and it only sends deltas across, so so it should be pretty efficient. Does it work as a background service? The sample I've got there works as is in the foreground. I see no reason why it shouldn't work in the background.
You can still use the network calls. I think you're obviously limited by whatever the background execution will let you do in terms of time.
So a background task is just code for your app that's running. Obviously, you haven't got any UI, but
and that's the same with what we saw before with the roaming settings as well on OneDrive. They could all run in the background if you wanted to.
Absolutely.
It's just a matter of choice.
Yeah. Yeah, so you've just got to call. You've got to make the calls to the Azure Mobile Services methods to cause the sync. So where you do that is up to you. It doesn't actually need to be your foreground app. Yeah, so it's flexible and powerful. Right, we haven't got a lot of time left, so I do want to do one thing, which is to talk about push notifications from the cloud as well. So again, all this is cross-platform. It's really cool. Now, basic push notifications. And all of the mobile infrastructures have the same basic layout. So what it tends to happen is your client app runs, it talks to your platform notification service, and that will return to your client app a kind of a unique client identifier of some kind to say this is you. You then have to send that to your own app backend logic, and then your logic runs, maybe it's a distribution system or something, whatever. You've got a reason to send a notification to one or more of your clients. And essentially it then has to use the cached client IDs, which actually is a URI in most cases, and talks to the platform notification service again, but this time to say, can you send a notification to these guys, please? So, but it means you've got a fair bit of complexity here in your app backend managing that list of your clients, and you've got to handle expired tokens because the IDs expire and this sort of thing.
Yes, very true.
It's not impossible, but it's just it's just stuff you have to do.
More work. You can't concentrate on your app.
So enter Azure Notification Hubs, which simplifies this fantastically. So obviously you've still got the first bit. You've still got your client and has to get a client address. But then what it does is it send it either via your backend or directly to your notification hub, Azure Notification Hub, which is a service sitting in Azure, and its notification hub handles all that registration and maintaining the list and pruning expired IDs out of it. It handles all that for you. And then your app backend talks to notification hubs and says send the notifications, and that talks to PNS and all of the logic to keep all this, all complicated HTTP stuff is all done for you. And also this notification hub is it's cross-platform. It can send notifications to iOS, Android, Kindle, and and our stuff.
Anything that accepts
notifications. So it's really cool, and Azure Mobile Apps uses notification hubs as well. So let's just add push notifications to this. Right, now then, what do? We go off to, this is our a client app. So I'm going to, first of all, I need to get a push.
Yes, you do.
I've got to register my app with the Windows Store. So I need to sign in, put in my Microsoft account, Andy Wigley at hotmail.com, and put in my password. And then sign into the store. There's two-factor authentication. So I need to put in the last 4 digits, 6539. And now it's going to send me a text on my phone here. It'll send me a text with a code, which I then need to put in. And I don't mind you seeing this because they expire once they're used. So you're not going to be able to crack my account. I'm still waiting for that to come through. Here we go. 562480. Submit that, and that'll allow me into the store. It's checking my developer account. So I'm doing this from Visual Studio, notice. You can do it from the dev.windows.com, from the portal. And now what I need to do is just reserve a unique app name, and it will check for uniqueness now. So I'm going to call this the To-Do 10240 app. Assume that nobody else will have
hopefully
created one
not, yeah. No. There might be a lot of to-do apps there.
Yeah, I think that might be probably a safe bet, because this is global uniqueness. It's not the name that people see in the store or anything, but it's your unique name, for identifying it.
That's what you want to call the submission.
Yeah, that's right. Yeah. So I've requested that name. It's now updating the app list yet again. So here we go. Right, we've got our name. Thank you very much. And then we say next, and then associate. So we can now say. So that's our package display name. It's got my publisher. Obviously, I'm registered with the store. And what that does is it adds to your project. It changes some stuff in the manifest and adds this XML file with your publisher ID and all that kind of stuff, and loads of other data that's relevant for that. But the important thing is here, what it has done. If we go off to Windows, dev.windows.com, go off to my dashboard, see all my apps. My publisher name is Applicious. We say accept. And now I can go for this To-Do 10240 app, I can go down to this, services, push notifications. And I need to go off, and I need to get, where is it?
It's that link, visit the live service.
Oh, yeah, okay, that's right. And it's in the middle there. So I need to go off the live services site, and I need to get from there my client secret, which you are going to see. I'm going to have to change straight after this. sign in there. And now here's the stuff that push needs to send notifications, and the notification hubs needs to know in order to be able to send. It needs a client secret, this guy, which we need to plug in to, here we go, back on the portal for Azure. You can just plug this stuff into here. It needs to know the package SID, so that's that. So that's a unique SID, the identifier for this app. Put that in there. And it needs that client secret. There we go, which I'm going to refresh straight after this. And we'll plug that in there, so that goes in. Now this is what Azure Mobile Apps uses now, and we update the notification hub, is using Azure notification hubs in order to handle notifications from our cloud service.
Okay.
So we go off now, and we go off here to, this is our to-do item controller. This is the cloud service logic that handles inserts, updates, deletes, CRUD operations against our service. So I just need to add a couple of namespace declarations. Let's see this. We need the collections.generics.
Yeah.
We need using Microsoft.Azure. Notification hubs, because we're talking to notification hubs.
Yeah.
And we also finally need Microsoft.Azure mobile.server config, because we're going to get we need that config details that we just plugged into the portal there. And right now, when we insert a new item, I'm going to plug in some code here. We're also going to send a post notification every time we insert a new item into the cloud. And so I've got this bit of code ready here. And it goes off to the portal and gets those two values that we just plugged in there, the notification hub connection string and the secrets, so the name and the connection. And then it connects to notification hubs, and there we are, we're sending a toast payload.
Okay, nice.
And then it sends it, Windows native notification async, and it could you could add that, you can expand that to send to iOS or Android or whatever clients you've got for this service. Right, let's publish this up. Publish it.
So this is now publishing to the Azure
back to the cloud. Yes, so this is, we've updated the code here on my dev machine. Now we're updating this, putting this updated version up to the cloud. There we go. And in a minute we'll get that nice, your app's running, but I'm not going to wait for that.
You get the smiley face.
You get the smiley face. We'll go and fix now we just need to add to the client. We need to add the code that's going to get our notification channel and send that up to the cloud so that it knows, a registration of our channel ID.
You haven't done that yet.
I haven't done that yet. So we've got TDCS4. Try this. Here we go. We've got init notifications async. Just need to resolve that. Push notifications channel manager. And that makes the call to push notifications to get our channel ID. And then we just send that channel.uri up to the mobile service. And we're going to call that from our onLaunched. And that should be enough to get all this working. There you go. We're creating a new channel and sending it up to the cloud.
Oh wow, so they've basically done all the running around for you.
Yep, that's right. And once we've done that, we're all set to receive notifications. You don't need to put toast capable into the manifest anymore with UWP. You used to have to do that on 8.1. Don't have to do that. So now we can add a new item here. So it now comes with push. And we can send that up to the cloud. There we go. And we should see, there we go. We've got a notification down the bottom there. Now it comes with push. So we've now push enabled our mobile app service as well. And there's lots more we could do, like, obviously I haven't added authentication. And there's that thing about the images. Like I said, I'm going to follow up with this on my blog, andywigley.com.
Nice.
Please try it out for free. You can actually get a free trial on Azure to try all this.
Yeah.
And you can learn more at that URI there, or you can tweet the team at Azure Mobile. So there we go. That was a run through all some of the ways you can cloud enable your app, and it's like crucially important for getting this connected experience thing. So across the user's devices, making sure that they have this connected mobile experience, which is a really good thing. We've looked at roaming data. Good for the settings, some
it's very lightweight.
Yeah. OneDrive, you're using the user's cloud storage to store files. So you need to get their buy-in for that. And then there was a good run through there of Azure mobile apps, and there's more it can do, like I say, like authentication against social networks.
You actually get a very rich set of features with it. Like
features,
it'd be a shame just to use it for that one piece. You can use it across everything.
Yeah, so we could talk about that. In fact, I probably will do another MVA later in the year where we drill a lot into all of these.
I think this is like a key topic for anyone doing UWP now.
Yeah, it's deserving of that. All right, we're going to take a short break, just a few minutes, and then we're going to be back to talk about kind of complementary, a bit more about push notifications as well, but more about tiles and this sort of thing. Shen, you're leaving me now.
You're
going to come back this afternoon.
I'll be back later this
and Nikolai's going to join me for the next session. So we'll see you in a few minutes. Well, you won't. I will.
See you later.